All right, guys, we are going to take a look at geometric applications. And what you might start to notice, gentlemen, is that the lessons that we're doing from here until the state exam are all going to be reviews of some of the objectives that have proven most difficult over the year. And so we want to give you some more time at bat with the objectives so that when it does come time for us to take the state exam, you have as much as possible fresh in your mind, and you can really show us how hard you've worked throughout the year. So let's go ahead and take a look here at our mini lesson. This swimming pool that is 125 square meters in area was designed so that sections of the pool can be used for different activities. The dimensions are given in meters. Okay, so here I have my pool, okay, and I have my length here, and it doesn't matter again what we decide is length and what we decide is width because of the commutative property of multiplication. I have my length here, so with my swim lesson section and the kids area, I have a total length here of 27 meters. All right, and I have my width here, and I know that my width is x plus 2 meters, okay? So I want to write an equation that can be used to solve for x. Well, I know that area is equal to length times width. Base times height is also fine. And I also know that the area here is 121.5 meters squared, okay? It's going to be equal to 27, that's my length, times x plus 2. That's my width. And so let's talk about what does the x in this equation represent. And so this x represents the width of the water therapy section. Okay, and now we want to solve our equation. So let's write it down again. I'm going to write it in the different order, just switching the sides of the equal sign. 2 plus x, all right, so this is my length plus times my width is equal to my area, which is 121.5. I'm going to go ahead and erase this section right here so that we can solve. Okay, so I do need to use, came back. Let's erase it. Okay. I do need to, came back again. All right, I'm not going to fight with it anymore. I do need to use the distributive property here, okay, and I'm going to be left with 27 times 2 is 54 plus 27 times x is 27x equals 121.5. Subtract 54 from both sides, subtract 54 from both sides, and I'm going to come up with 27x is equal to 67.5. All right, let me bring that up here. 27x is equal to 67.5. So I'm going to divide both sides by 27, divide both sides by 27, okay? And I'm going to come up with x is equal to 2.5 meters, all right? So if I go back up here, this part, this x is equal to 2.5 meters. Make sure you have all of this down. And we'll take a look at a couple of the independent practices too. Okay. A rectangle has, so it's important that it's a rectangle. A rectangle has a width that is 3 inches shorter than the length. All right, and so I'm going to go ahead and think that's L minus 3. The perimeter of the rectangle is 22 inches. write an equation to solve for the length of the rectangle, okay? So here's what I know. I know that my perimeter, so sort of my key information box, I know that to find perimeter, I do length plus width plus width. Slightly better way to write that would be 2L plus 2W. Okay, so let's draw and label a diagram. All right, so I have my length here, and I'm going to make it kind of a swirly L so we don't think it's a 1. And then I have my width, which is L minus 3. L minus 3. Okay, so I need to turn that into an equation. Okay, so I could do this. I'm going to go P is equal to L minus 3 plus, I'll make it a squiggly L, L minus 3 plus L plus L. But we can combine our equations, okay? And I do have these 4 L's sort of floating off by themselves, and I can combine them, and I can say P is equal to 4L, all right? Because I had my 4 L's right here. 1, 2, 3, 4. I can combine those, and then I can combine these two negative 3's right here. So P is equal to 4L minus 6. Okay. So what does the variable represent? We're going to do this again. Bear with me, guys. Okay. So what does the variable in your equation represent? I have P is equal to 4L minus X. So let X, so the L is equal to length. All right. So solve the equation, including units, and then evaluate it using substitution, which means I'm going to solve and check. Okay. So I'm going to go 4L minus 6, 4L minus 6 is going to be equal to the perimeter, which I was given, 22. All right. So I'll add 6 to both sides, plus 6, I get 28. I'm left with 4 times L. Divide both sides by 4. All right. And so my L here is equal to 7. Now I'm going to plug that back in and check it, right? Which is a great thing that we can do. So I'll do 4 times L minus 6 equals 22, and we're going to see, is this true? So is 4 times 7 minus 6 going to be equal to 22? Well, let's see. I do 28 minus 6. It does, in fact, give me 22. So I did a good job here, guys. 22 is, in fact, equal to 22. So the length, because it says make sure to include units, the L is 7. I'm going to make sure it's inches. The length is 7 inches. Okay. So now we need to find the width. What is the width? Okay. Well, if my width is equal to my length minus 3, and I know that my length is 7, then my width is going to be equal to 7 minus 3. All right, so my width is going to be equal to 4. And now I can use this information to find the area. Area equals length times width. So in this case, area is going to equal 7 times 4. Okay, which means my area is 28 inches squared. Okay, and I'm going to pause right here. You guys are going to do the rest of the independent practice and the exit ticket on your own. And hopefully we will be able to introduce something else on the computers today. Good luck, good work.